Hello. In this video, we will review a few questions and problems from the objective 2.1 about the center of mass for a system of particles or for a non-uniform object for the 11 ASP mechanics course. Now, the main idea is that if we have an object that is symmetrical and it has a uniform density, then its center of mass will be exactly at the point where the diagonals cross-section meet. So this is the location of the center of mass with the x coordinate and the y coordinate of the center of mass. Now, if we have a system of particles or a system of objects that has or an object that it is made from two or more particles, then we have a position 1 of the first system of object and a position 2 of the second object. And if the mass 1 and mass 2 of the two parts are known, we can find the location of the system of mass from this equation. And for an object that has non-uniform density, now the law is very similar. It's just that the center of mass position is equal to the integral or the sum of the x times dm divided by the integral of dm. Now, what we need to do is, usually there will be a given linear density lambda, so first thing that we'll need to do is solve for dm, which is lambda times dx, and replace this dm in these laws. Now, the integral of dm actually means what is the total mass of the object. Let's see how we can answer a few questions. Now, for the first question, we have a given system of two particles. So we have a particle 1 and a particle 2, and we need to find the location of the system of the center of mass. Now, the important part that we need to do is say that for the first object that has a mass 1, there is a given location x, so the x1 is -4. If necessary, we'll work for the y1 as well, then the y1 is 3. And for the second object, the mass 2, we have the y and the x, so the x2 is equal to 5 and the y2 is equal to 6. And if we need to find the location x, y of the center of mass, we can say that the x of the center of mass is equal x1 times m1 plus x2 times m2 divided by the total mass m1 plus m2. The x1 we say that it is 3, the m1 is 5, plus 5 times the m2 is 15. All of this divided by 5 plus 15. So this is 15 plus 75 divided by 20. So this is 90 over actually I made a mistake, sorry for that. The x1 is not 3 as I said, the x1 is -4, so -4 times 5, and this is -20 plus 75, so it is 55 over 20. The result is 2.75. Now, obviously the answer is A, however, maybe we'll need to find the location y of the center of mass in some cases. So if we apply a similar law, y1 times m1 plus y2 times m2 divided by m1 plus m2, we know that the y1 is 3, we know that the y2 is 6, divided by the total mass that it is 20. So 15 plus 90 divided by 20, this is 105 divided by 20, and this is 5.25. And we can move on to the next question. As always, feel free to pause in order to read the question more thoroughly. Now, what we have here is an object that is not symmetrical, at least on the axis up and down. It's not symmetrical through its x-axis. However, in order to find the center of mass, we can break it into a system of more simple objects. For example, I will break it into an object 1 on the left, an object 2 at the center, and an object 3 on the right. And what we can say is that the first object, since it is symmetrical, it has the center of mass exactly at the center, so we can say that the x1 is equal to 1 centimeter, and the y1 is equal to 2 centimeters. Now the x2, it is 3, and the y2, it is also 3, and the x3, it is 5, and the y3, it is 2. Now also we don't know the mass of each block. However, we can say that the mass, since we have a uniform sheet, a uniform object, the mass is proportional to the area. So we can consider that the mass 1 is proportional to the area of the first object. The area is length times width, so 2 times 4, 8. The mass 2 is proportional to length times width, so 2 times 2, 4. And the mass 3, it is proportional to, again, 2 times 4, it is 8. And now that we have a clue about the x1, x2, x3, and all the masses, we can say that the x of the center of mass is equal x1 m1 plus x2 m2 plus x3 m3 divided by the total mass. Again, we don't know the masses, but we know that the masses are proportional to the area. So x1 is 1 times 8 plus x2, which is 3 times 4, plus x3, which is 5 times 8, all of this divided by the total mass, 8 plus 4 plus 8. So 8 plus 12 plus 40 divided by 20, this is 60 over 20, the result is 3 meters. Now, since we have two options with 3 meters as the x of the center of mass, we need to calculate the y of the center of mass, which is obviously going to be a little bit more than 2. I believe that the correct answer will be B, but let's verify this. Y of the center of mass is y1 m1 plus y2 m2 plus y3 m3 divided by the total mass m1 m2 plus m3. A little bit carefully, the y1 is 2, the y2 is 3, and the y3 is 2 again, divided by the total mass that we know that it is 20 from the previous part. So it is 16 plus 12 plus 16 divided by 20. This is 32 plus 12, 44 over 20, and this is again 2.2. So our hypothesis was correct. Let's move on. We have something very, very, very similar. I can pause the video and you can attempt to solve the question, or you can pause the video and attempt to solve the question. However, again, we break this complicated object into 3 more simple blocks. So we have the x1 as 1 and the y1 again as 1, and since we need to find the center of mass, we'll need something about the mass. The mass is related to the area, so we can say that mass 1 is length times width, so 4. In a similar way, the x2 is exactly at the center. Now the center, if we can calculate it through the diagonals, we can see that it is at position x, sorry about that, at the position x that it is 3.5, and the position y that it is 2.5, and the mass 2 is proportional to length times width. The length is 3 and the width is 3, so 3 times 3 is 9. And in a similar way, the y and the x of the third object are at locations x3, it is equal 6.5. Sorry for that. x3 is equal 6.5 and y3 it is 2, and the mass 3 it is length times width, so 3 times 4 it is 12. Now that we have all of this, it is very easy for us to calculate the center of mass. Most likely the x of the center of mass will be somewhere on the right side after 4 meters, so maybe 4.5, maybe 5. Let's see, maybe we are lucky and we'll just find 5. So x1 m1 plus x2 m2 plus x3 m3 divided by m1 plus m2 plus m3. So 1 times 4 plus 3.5 times 9 plus 6.5 times 12, all of this divided by 4 plus 9 plus 12. Now we'll need the calculator for this. So 4 plus 3.5 times 9 and then plus 6.5 times 12. All of this divided by 4 plus 9 plus 12, and the result is 4.5 meters. Now unfortunately we have two options with this 4.5 meters. Now with common sense we can say that the center of mass will be just below the 2 because there is more mass under this y is equal to, so most likely the correct answer is E. Not most likely, for sure the correct answer is E. However, maybe we need to verify this with some calculations. So the y of the center of mass is equal y1 m1, so 1 times 4 plus y2 times m2, 2.5 times 9 plus y3 times m3, so 2 times 12. All of this divided by the total mass, and you will give me a second for this. So 4 plus 2.5 times 9 plus 2 times 12 and divided by 4 plus 9 plus 12. The result is 2.02. Now either I made a mistake in my calculations, let me try again, or we have an issue at the givens. Well, there is an issue at the givens. I made a mistake with the second object. The y2 is not 2.5. The y2 is 1.5 if we look carefully. So the y2 is 1.5, and I need to change this 1.5 times 9. So let me repeat my calculations. That's why we found the wrong answer before. So 1 times 4 plus 1.5 times 9 plus 2 times 12. All of this divided by 4 plus 9 plus 12. And indeed the result is 1.66, or very, very close to 1.7 meters. Now we go to a question that is related to a non-uniform object, and this is the kind of the questions that makes our life a little bit difficult. Now what we have is an object that has a total mass of 0.195 kgs, and we know that the length is 0.15 meters, and it has a non-uniform density that it changes with position according to this equation. Now let's explain what this means. This means that the density of the object changes with the density. For example, when the x is equal to 0, if I go to the location x is equal to 0 and I replace the value of 0 in this equation, then the density it is 1. So on this location the density is 1. If I go to a little bit higher position, let's say 0.05, so 4 times 0.05 plus 1, so the density will be 1.2. And if I go to location 0.1, so 0.1 times 4 plus 1, this density will be 1.4. And in a similar way, the density here will be on the density on the position 0.15 it will be 1.6. So an object is, the density of the object increases as the location x is to the right. So there is more mass on the right side, less mass on the left side. So I don't know exactly where the center of mass is, but I suspect that it's going to be at a distance greater than 0.75. So maybe 0.081 or maybe 0.1 or maybe 0.123 meters. So on the right of the center of the object. However, in order to find the exact location of the center of mass, I need to do a little bit of calculus, and I need to take the formula for the position of the center of mass, that it is integral of x times dm divided by integral of dm from x is equal 0, from x initial to x final, the x final is 0.15. And again, the same thing from the initial position x is equal 0 to the x final, that it is equal 0.15. Now, these two integrals create a little bit of trouble for us because the integrals have a variable m, but what we have as a variable is the distance x. So in order to overcome this problem, we say that this density, it is a linear density, so we can call it dm over dx, mass over position, mass over length. And we solve for dm, so the dm is lambda dx. So wherever we see dm, we can replace 4x plus 1 dx. So my integrals now become integral from x is equal 0 to x is equal 0.15, x times, again, wherever we see wherever we see dm, we can replace 4x plus 1 dx, and again integral from x is equal 0 to 0.15, wherever we see dm, we can write 4x plus 1 dx. Now, we have integrals of x and variable x, so these integrals can actually be calculated. Now, the bottom integral, it is the total mass that it is given. I actually don't need to calculate it. I know that the value will be 0.195. However, let's verify this from the calculator. So if I open an integral and I do from 0 to 0.15, 4x plus 1, we get that the value is indeed 0.195. And for the top integral, I cannot calculate it immediately. First, I need to eliminate the brackets. So from x is equal 0 to x is equal 0.15. X times 4x, it is 4x squared, plus 1 times x, so plus x dx. So now we can actually calculate the integral in the numerator. So integral from 0 to 0.15, 4x squared plus x, and the calculator gives us as a value 0.01575, and if we divide it by 0.195, we find that the location of the center of mass is 0.0807 meters, approximately equal to 0.081 meters, as we suspected, a little bit further away from the center of the object. We can try to do a similar question. We can try to answer a similar question. If you want, feel free to pause the question and answer it yourself. However, we need to find the mass of the rod and the center of mass. Now, the formula for the center of mass in case we have an object of non-uniform density is integral from x initial to x final x dm divided by integral of from x initial to x final dm. And we know that the dm is equal, the linear density lambda is equal dm over dx, so the dm is lambda times dx, and this means that the dm is, wherever we see lambda, we can place the value of the linear density for x dx. Now, the bottom integral is actually the total mass of the object, so we can say that the total mass is integral from x initial, so from 0 meters to 8 meters, wherever you see dm, we can say 4x dx. So all we need to do is open an integral from 0 to 8 for x dx, and the value is 128 kilograms. Now, since we have a linear density that depends on position and the linear density increases with position, then just like before, the center of mass will not be exactly at the center, but I expect that the center of mass will be somewhere on the right side because it is heavier. So maybe the answer will be 4.21 or 5.33, maybe 5.73. So probably one of these three values. Now, the bottom integral we have already calculated is 128 kilograms. The top integral is from x initial, so from 0 to 8, x times dm, so x times 4x times dm, x times 4x times dx, since the value of dm is 4x dx, and 4x times x, it's actually 4x squared, so 4x squared times dx. And we need to actually find the value of this integral, which is 682. However, if we divide it by 128, I believe that we'll find 5.33. Indeed, 5.33 meters. And one last question from a past exam from a long time ago, where we have a wire that we bent it and we need to find the x and y coordinates of the center of mass for this wire if we know that it forms a triangle. Now, a little bit carefully, we can consider that this wire is made by 3 separated wires, and if we're talking about the x-axis, the first wire has an x1 exactly at the center, so 12. The second wire, if we're talking about the x-axis, the location of the center of mass, the x2, is 0. And for the third wire, the location of the center of mass, if I project completely downwards, although the length of the wire is 26 centimeters, the location x is right above the x1. So actually the x3, it is again 12 centimeters. So if we take the rule that the center of mass xcm, it is equal x1 m1 plus x2 m2 plus x3 m3 divided by the total mass. The x1, we know that it is 12. The mass one, we don't know it, but we can consider that the mass is proportional to the length. So the mass could be 24 plus the x2 is 0 multiplied by the length, that it is 10, plus 12 multiplied by 26, and all of this divided by the total mass, where it is the total length, 24 plus 10 plus 26, it is 60. So the x location of the center of mass is divided by 60, it is 10. Unfortunately, we have two values with the x of the center of mass is equal 10, so we have to find the y of the center of mass. Now, the y1 is 0, the y2 is 5, and again, the y3, it is 5, because if we project to the left, well, the object is symmetrical, so the projection left will be exactly at the center of the 10 centimeters. So the y of the center of mass is, in a similar way, y1 m1, so 0 times 12 plus y2 times m2 plus y3 times m3 divided by the total mass, which is proportional to the length, so 60. So 50 plus 60, it is 110. I think maybe I made a mistake in the calculation, so the the y1 is 0, but the m1 is not 12, it is 24. I made a mistake in my calculations, excuse me for that. So 24, this doesn't make a difference, but because it is 0. 5 times 10 is correct, but the last part is not 5 times 12, it is 5 times the length, which is 26. So 5 times 26 plus 50, and then divide by 60, the result is 3. So the best option is D. Thank you for watching. Feel free to email me with your comments and your questions, your inquiries. Have a good day.